Good afternoon to all of you. Today I am going to cover the titanium and its alloy. Titanium is named after the Titans, the powerful son of the earth in Greek mythology. Titanium is the fourth abundant metal on earth crust after aluminum, iron and magnesium. Not found in its free form, pure metal form in the nature but as oxide, that is ilmenite and rutile, found only in small amount in Thailand, have similar strength as steel but with a weight nearly half of steel. Due to this property, it is used in the aircraft where light weight is required but having the high strength. History of titanium. In 1789, Rev. W. Gregor discovered titanium dioxide in rutile. 1795, Clayforth rediscovered titanium dioxide and recognized it as the oxide of a metal to which he gives the name titanium. During 1821, Rose reports on titanium, its oxide and sulfide. These were the first report on pure component of this element. In 1825, Berzelius isolated metallic titanium. In 1869, Scone reports yellow color produced by reacting titanium salt with hydrogen peroxide. Physical property of titanium: its crystal is structure is SCP below 882.5 degrees Celsius and above 882.5 degrees Celsius. It is having BCC, body centered cubic structure. Atomic diameter 0.320, density 4.54 gram per centimeter cube, melting point 1667. Its atomic weight experience it experiences allotropic transformation, alpha phase transformed to beta phase at temperature of 882.5 degrees Celsius. Highly react with oxygen, nitrogen, carbon and hydrogen. Difficult to extract, expensive. Used mainly in wrought form for advanced application where cost is not critical. High strength and toughness. Description of titanium. Titanium when pure is a lustrous white metal. Titanium minerals are quite common. The metal has a low density 4.5 gram per centimeter cube compared to aluminum 2.69 gram per centimeter cube, copper 8.96 gram per centimeter cube, iron 7.88 gram per centimeter cube. It is having more than aluminum but less than copper and iron. Superior strength to weight ratio, it is twice as strong as aluminum. High temperature strength up to 650 degrees Celsius. Can be easily fabricated. Has excellent corrosion resistance. It is nearly as resistant to corrosion as platinum. The metal burns in air and it is the only element that burns in the nitrogen. It is marvelous in only one element that burns in nitrogen. It is marvelous in firework, low electrical and thermal conductivity. Advantages of titanium alloy: low specific gravity, high specific strength, 3 times as aluminum and higher than steel. Non-magnetic property, biocompatible material, high corrosive resistance to seawater and most corrosive condition. Density of selected material. Here you can see in the graph. The graph is plotted between specific strength at y-axis and temperature at x-axis. Titanium alloy. This is the region covered by the titanium. Above titanium comes carbon fiber reinforced composite. Here single crystal superalloy. Superalloy can sustain high temperature up to 1250 degrees Celsius. Titanium can sustain up to 650 degrees Celsius. Steel can sustain up to 1200 degrees Celsius. Aluminium alloy can sustain up to 500 degrees Celsius. Titanium uses Titanium is used for alloys with aluminum, molybdenum, magnesium, iron, and other metal. These alloys of titanium are used principally in the aerospace industry for both airframe and engines, where lightweight strength and ability to withstand extreme of temperature are important. Its excellent corrosion resistance provides application in chemical processing equipment, marine component, and biomedical implant like joint replacement part, including hip ball and socket. Use of titanium continued. It has excellent resistance to seawater and is used for propeller shaft, rigging and other parts of the ship exposed to salt water. Titanium alloy are considered biocompatible, that is, they are not rejected by the body by developing porous coating of bone-like ceramic composition known as hydroxyapatite. It may be possible to make titanium implant bioactive. That is, the natural bone can grow into the hydroxyapatite coating. A titanium anode coated with platinum provides cathodic protection from corrosion by salt water. Titanium paint is an excellent reflector of infrared radiation and is extensively used in solar observatory where heat causes poor viewing conditions. Continued pure titanium dioxide is relatively clear and has an extremely high index of refraction with an optical dispersion higher than diamond. It is produced artificially for use as a gemstone, but it is relatively soft. Sapphires, and rubies exhibit their extreme as a result of the presence of titanium dioxide. The dioxide is used simply for paint as it is permanent and has good covering power. Pure titanium dioxide is relatively clear and has extremely high index of refraction. Application. Because of this characteristic, titanium is a candidate material for the first wall of magnetically confined fusion reactor. The hydrogen-based plasma is not detrimental since at 5000 degrees Celsius and 1 Pascal pressure, the titanium does not pick up enough hydrogen for embrittlement. An additional feature is that titanium resists swelling due to neutron damage. This is the end of this slide. Next, more slide is there. Titanium is resistant. Info on titanium is resistance to dilute sulfuric and hydrochloric acid, most organic acid, chlorine gas, and chloride solution. Titanium is present in meteorites and in the sun. Some lunar rocks contain high concentration of titanium dioxide. Titanium is widely distributed in the universe. Its concentration within the Earth crust is of about 0.6%, make it is the fourth most abundant of metal after aluminum, iron, and magnesium. Pure titanium melts at 1670 degrees Celsius, ideal to use component for elevated temperature. Reaction. The picture shows the result from adding titanium powder to a burning mixture of potassium chlorate and sucrose. Do not attempt this reaction unless you are a professionally qualified chemist and you have carried out a legally satisfactory hazard assessment. To a burning mixture of potassium chlorate. Adding titanium powder to a burning mixture of potassium chlorate and sucrose. Do not attempt this reaction. More reaction. This picture shows the reaction between titanium metal and potassium perchlorate. Importantly done. This reaction is Improperly done, this reaction is dangerous. Fun fact: Titan means titanium in French. Titan means titanium in German. Titano means titanium in Italy. Titanium means titanium in Spanish, Sweden. Problem with titanium alloys. Titanium can catch fire and cause several damage in circumstances where it rubs against other metal at elevated temperature. This is what limits its application in the harsh environment of aero engine to region where the temperature does not exceed 400 degrees Celsius. Consequence of titanium fire in an aero engine. Nickel alloy blades have been burned away. Photograph courtesy of Dr. Yamsuk. The world production of titanium is nevertheless very small. 80% of all the titanium produced is used in the aerospace industry. Car suspension spring could easily be made of titanium with a great reduction in weight, but titanium is not available in the large quantity needed and certainly not at the price required for automobile application. The price of a mill product is in the excess of 25 pounds per kg compared to 5 pounds per kg for steel. This is principally due to titanium's strong affinity towards oxygen, both during extraction and downstream processing. The target price for titanium need to be reduced to about 30% of its current value for serious application in mass market car production. Pure metallic titanium pure was first prepared in 1910 by Matthew A. Hunter by heating titanium tetrachloride in a steel container at 700-800 degrees Celsius known as Hunter process. Titanium was not used outside the laboratory till 1946 when William Justin Kroll produced it by reducing titanium dichloride with magnesium known as Kroll process. Titanium primary production Kroll process. Titanium common in earth crust in energy to separate 125 megawatt hour per ton. $4 per kg just in powder. Batch production over 5 days. Produce titanium dichloride, tetrachloride from titanium dioxide and calcium dicalcium. This is the reaction. Subsequent processing. Ingot, bloom, from the raw material titanium sponge to process manufacturers of electrode, double melting ingot, and here you can see rolling mills, forging machine. Crystal structure of titanium. Alpha room temperature to 883 degrees Celsius. Hexagonal closed pack structure usually strong but brittle, not easy to form into various shapes. Beta phase body centered cubic, the same as the steel at room temperature. Less strong but not so brittle. Slightly easier to form into different shapes. The property of commercially pure titanium are largely determined by the oxygen content. Crystal structure. The crystal structure of titanium at ambient temperature and pressure is closed pack hexagonal with a C by A ratio of 1.587. Closed pack. Slip is possible on the pyramidal, prismatic, and basal plane in the closed pack direction. At about 890 degrees Celsius, the titanium undergoes an allotropic transformation to a body-centered cubic beta phase which remains stable to the melting temperature. Molybdenum and vanadium have the largest influence on beta stability and are common alloying elements. Tungsten is rarely added due to its high density. Copper forms titanium dicopper, which makes the alloy age hardening and heat treatable. Such alloys are used as sheet material. It is typically added in concentration less than 2.5 weight% in commercial alloys. Zirconium, tin, and silicon are neutral elements. Those do not fit properly and causes changes in the lattice parameter. Hydrogen is the most important interstitial body. Central cubic titanium has three octahedral intrinsic per atom, whereas closed pack has one per atom. The latter are therefore larger, so that the solubility of oxygen, nitrogen, and carbon is much higher in the alpha phase. Interstitial titanium is capable of absorbing up to 60 atomic weight percent of hydrogen, which can also be removed by annealing in a vacuum. Hydrogen enters the tetrahedral holes, which are larger in BCC than CpG. Thus, the solubility of hydrogen is larger in beta. The enthalpy of solution of hydrogen in titanium is negative. Alloy addition on titanium. First diagram is the titanium phase diagram: titanium tin, titanium aluminum, titanium molybdenum, titanium manganese. Addition of AE influence the alpha to beta transformation temperature. Alpha stabilizes aluminum, copper, and beta stabilizes vanadium, chromium, molybdenum, manganese, tantalum. Titanium alloy contains 92.5% titanium, 5% aluminum, 2.5% tin, are strong and maintain their strength at high temperature. The 90% titanium, 6% vanadium alloy can be readily welded, forged, and machined. This alloy is used for both high and low temperature application. Example: rocket motor cases, turbine blades. This is the titanium alloy. Commercial pure titanium: alpha titanium alloy, beta titanium alloy, alpha beta titanium alloy. Alpha titanium alloy: titanium, 8 aluminum, 1 molybdenum, 1 vanadium. Beta titanium alloy and alpha beta titanium alloy. Property of titanium alloy: alpha titanium alloy is strong, high strength at high temperature, less than 883 degrees Celsius, good buildability, difficult to work, non-heat treatable, stress relieving, and annealing. Pure alpha alloy. Property of titanium alloy: near alpha titanium alloy microstructure. Heat treatment of titanium alloy. Titanium aluminide. Alpha beta alloy heat treatment: quenching, heat quenching, tempering. Next I am going to stop